and welcome to today's webinar. Today we're going to be talking about the DataGraph commands, things that have been modified in version 5.0. First of all, in terms of the commands that changed with DataGraph 5.0, we didn't have any major changes in commands, but there's a couple of things in particular that I want to point out to you, some that are a little bit less significant, just minor things, just that are things we added based on comments to be aware of. So we're going to talk about that. We're going to talk about for those of you who actually attended the webinar that we did or have been able to see it online on the functions. We'll talk about the fit command just briefly today. Then we're going to talk about briefly a change in the connect command. We're going to talk about the region command and how we've added the ellipse as a shape that you can draw. And we will also talk about some options in the scalar field command and actually one bug that someone identified that we didn't see when we released 5.0 that is fixed in the beta. You won't see this in all your files, but there was someone who had an issue on the discussion board. Anyway, so basically the scalar field has these different smoothing options available that weren't there before for the contours. First thing we'll talk about is the fit command. Again, briefly, we're not going to go into too much detail. The other webinar that we did went into a lot more detail on various ways that we added the function library and how there's a new evaluate option that you can use the both fit and function command with. But what I just want to point out for you, for those of you who haven't seen that, also there's a new example file for exponential fit that we just added. So if you want to open that up just quickly, this file actually I think has a couple of interesting things in here. If you've never used tokens or aren't familiar with what I mean when I say the word token, tokens are these blue objects that you see that are these that add labels and can also add variables as text labels into your graphs. So for this file, for example, this is an exponential fit of some data where there's a decay. And there was someone asking about how can I calculate the half-life from this data? In fact, this is something we are thinking would be a reasonable output from the exponential fit. So you wouldn't have to even do this at all. But for now, if you wanted to calculate the half-life, this shows you how you can do that in a variable. And then what it also shows you is that you can do this within a token. So in this first file, notice how there's a title given and the half-life is shown here. This combines both some text that we put in here with the token. So I will just delete this just to show you what this does. So right over here on the right-hand side of the text box, I can click to see what available variables there are for me to add as a token. I select this, hit enter, and now you can see, well, that value was already there. But if you want to change the number of digits shown, then you can click on the right-hand side of the token itself and you get these options for changing the digits. So this file kind of walks through that process for you if you want to go back and look at this. But the other thing I wanted to show you over here is how this also walks through the steps, and I'm not going to go through this in detail, but for how you would change the legend for these commands. And here it just has the half-life within the legend itself. So here's the exponential fits. And if you expanded this, actually, let me swap the layout here so we can see these. So if you expand one of these out, you can see how we change what's in the legend at the bottom of the command itself. So here I have typed in the word half-life. I've added the power is in the exponent, that's the coefficient here within this fit. And if you click on this, there is an ability to actually do a simple calculation within the token itself. So for whenever tokens are referring to numbers, then you can actually type in a function that will derive a value from whatever number is being used. Anyway, okay, so I just wanted to show you a little bit about this file since this is new, and I think it is useful for showing you how to use these, again, use values that are coming out of the various commands for, doing labels and formatting things. But the specific difference that I want to point out to you in the fit command relates to the number of digits that you see within the fit function itself. So this fit command is fitting the X column time versus the Y column here is 1, and it's using the exponential fit. So it's just populating the result of the fit here when you select that. So say I wanted to put this in another file or draw this function, one way would be just to select this, and I can do copy. I just did Command C, but you can do edit, copy that. And then in a new graph, if I wanted to draw this function, there is a command for graphing functions that you can add. And I can just plop that in there. Again, in this file or other files, I can change the range that's drawn. And what this does now is it ensures that the function you see here has the correct numbers of digits in the coefficients to draw this properly. This really isn't as big of an issue for linear fits and exponential fits, but for polynomial fitting, the number of digits you have when you do higher order polynomials can be very important in terms of if you want to draw it. We actually talk about in the webinar that we did on functions about how really using the evaluate option is better for those higher order polynomials. So anyway, so I just wanted to kind of point that out just so you can see that difference. And I guess just to be clear, if I go back to this function here, what you used to have was a little slider here that you could change the number of digits. So that's what you don't see anymore. You don't have that slider changing the digits. It's just showing you that number of digits. And if you want to report this as a label and change the digits, then we would use the tokens to do that. So I could, within the legend here, for example, I could show that equation, pick those coefficients, and then change the number of digits that are shown by using that menu, built-in menu in the token itself. Okay, so let's keep going, and let me close this file. Don't need this anymore. And then the other thing, we'll go through this very briefly. We'll open a file that has the connect command. Here's a file that is what we'd call a slope graph because it's connecting two locations with a line with a slope in between them. And the connect command lets you, do some nice formatting on that to create some interesting looking graphs. But the minor change that you'll see in the connect command is that if you're adding a label, then you can do this and have the labels here. Let me just type in a word here. So now you can see the labels here on the left-hand side. I had this set to one of the columns, but if you wanted to type this in, you could have them all have the same labels. And what you'll also notice is that over here on the right-hand side, you could now use a variable for your label. You can use a token. That's sort of a minor change, but something that, again, was requested and certainly seemed like would make a lot of sense to allow tokens within this field as well. Okay, let's keep going and move on now to the next command that I wanted to talk about. Okay, just delete that one too. And the one here that we want to get into and spend a bit more time on is talking about the region command. This is a new file that's just been uploaded this morning. You can see the region command, draw a circle or ellipse around a region to highlight a cluster of points. Let's go ahead and open that file. And what you'll see are 4 different graphs, and this is sort of in the style that we've been working on for the example files in general, where the first graph shows you a graph that doesn't have as much formatting. It's using the essentially sort of the default format, maybe a little bit of formatting here. And then as you go through, there is, more formatting. So to give you some ideas of how you could use these commands and create graphs of different types. So first of all, what do we see here? Well, if you're not familiar with the region command, this is a command that allows you to draw circles, rectangles, rounded rectangles, and now ellipses. And what's really key here in terms of understanding the region command is that we're drawing these shapes and that the shapes themselves are not drawn as a layer above the graph in terms of, if you think about if you draw shapes in PowerPoint or something like that, you draw a circle, you drag the circle around, it kind of overlays what you see. Here, the way that the shape is configured is it is existing within the XY coordinate space. That means if I change my graph in terms of the aspect ratio or the sizing, then notice how where these points are located are not moving in or out of the region that's been highlighted. And that's kind of the key thing here. This isn't, really meant to be a drawing command in the way that you would, again, maybe draw shapes in, in other programs, but it really is, again, as we like to do things, very data driven. So for example, and actually I did say circle, but in fact, you don't see circle as an option here. This is actually using the oval option. So here's this is a region command, and you can see the options in this menu. So let me just show you quickly, how do we add one of these commands? So I'll start with a new graph, and you can see I have some data here. These are just some randomly generated numbers. Let's go ahead and highlight the X and the Y column and add these points. Let me make these solid just so you can see these maybe a little bit better. So if I want to draw and highlight these points, then I can add this command under the label button. You'll see here's the region. I'll go ahead and add that. And by default, it's adding an oval shape. If you go ahead and change these shapes between either of these, what you'll see is that they all overlap, or what am I trying to say? The rounded shapes are all contained within the rectangular shape. So if I actually, let me highlight this command and then make a copy of it and change this to a rectangle. Can you see here how the oval, or in this case, this is the ellipse, is contained within this outer rectangle? And you'll see, because I just made a copy of this, you can just, if you don't know how to do this, you can just copy a command and do Command C, Command V to make a copy. But these currently have the same range selected as the outer portion of this. So, and if I, you can also type these in. So right now, this is just placed, when I placed it placed it in the center of my graph. You can see if I change this, I can click and change this, the Y settings here. So this is showing me where X starts and ends, and where Y starts and ends to define this rectangle. So if I changed my Y beginning and ending, I can just copy those here into my ellipse. And again, now the ellipse is going to be contained within that rectangle. The ellipse also has this rotation option. If you attended one of the webinars where we demoed this when it was still in the beta, I don't think we had this as a slider yet. So this gives you a little bit more control over changing the the orientation of the ellipse kind of, but again, it's contained within that X and Y region. This is why one of the ways that you can place an ellipse in a specific location is there's sort of two ways to approach it. You can take the ellipse itself and you can click, if you click anywhere on it, you can drag it around and let's see, move the ellipse, but you can see actually the control points here. I'm actually not getting it right now. There we go. So this changes the ellipse, but it can be, and we recognize that you can click and move it around, but finding the points to drag it are something that, oh, there we go. I just clicked on the end and dragged it to the right. And now I could, rotate that. But let me hide this, because what may be easier for you is just to take the rectangle itself to encompass the points that you want to place in the ellipse, and then change this to an ellipse. And then you can, again, kind of go ahead and move this around. And notice actually right now how it's changing what am I trying to say? The range of my graph is changing as I move around this ellipse. That's actually a setting within this command itself. So if you go into the region command, again, I can also swap by clicking that bottom corner. Open this up. You see how there are two buttons here. There's an include in range and clip with axis range. So if I uncheck this and I moved my ellipse out of the range, it's no longer changing the X and Y axis range. I think I'll just undo that and leave that in the range. But anyway, depending on whether or not you actually want that to happen. So anyway, so that kind of shows you, I guess, a little bit about the, how it moves around. There's really two control points here, above and below, where if you click the lowermost point, you can drag this down. There we go. But if you, again, click in the middle, it will move around the whole ellipse itself. And let's see if I could drag that up a little. Yeah, again, it's not meant to be particularly like the way a drawing command is. It is, since it is data driven, it is very much a different way of drawing these points. Let me see if I can just drag this guy out a little bit. There we go. And then I can kind of move this to encompass my values. So now that I have one of these set up, again, if I change the way this data is, the points that are in it now are always going to be within that ellipse. The other examples that we have within this file show you, again, here's two ellipses. And then what else that you can do with this command is you can also add labels to any of these shapes. So here I have the points and the ellipse itself. And if you want to look into any of these, you can see how I've set both the line style for the ellipse and the text for a label, where I've typed in a label here. You could also use a token or a variable. This color now they're all color coordinated to what we have actually that was such the error color. We want it all to line color 1. So then if I decide to change that, I can do that up in the style settings. If I changed line color 1 to something different, then you'll see how all of these objects that are drawn using that color all change together. So that's one approach that's demonstrated here. The other thing, let's see, other file that's here, other graph, is now one where we've set the size very specifically. So if I take this graph, for example, and let me go ahead and make a clone of this so I can change this around a little bit. And I change the size to something specified. Again, the points are all going to stay within those regions. my points now are a little bit big, so I have these still all set to the local points variable, so I can make those a little bit smaller. And I can also change, I have some control over where this label is drawn. So right now, the label for this shape is drawn above. I could change this to be drawn below the shape, for example. So the last thing that I wanted to talk about is to talk about the scalar field command. And let me go ahead and actually, I'll just minimize this in case I want to bring this up again. And there's also a new file that we added into the online examples, contour lines and color ramps. So if you want to open up this file, you can see the data here. This is using a data set from a volcano. This is also a data set that is in R. Here, what we've done is we've used what we call flattening the data to have it all in one single column. If you're not familiar with that and you want to try this out, this gives a link to where the original data is. And there's an article on the help on how to flatten data. So taking a wide data set, making it all in one column. Anyway, that's what's done here. But what I want to show you in terms of what is different in the scalar field command is that we added in, actually, maybe I should just, let me show you quickly how I do this in case none of you have done this before. So I have this one column and it was originally, or I have this single column. This was originally multiple columns where the column header had V1 or V2 or V3, and this flattening action just puts it all in one column. So if I make a scalar field from this, I would go into the draw, add a scalar field, and my values would be this column. So I can click with my column header, drop it on this menu. But what the scalar field requires you to do is to specify the layout of the data. And there's a lot of options actually for how data can be laid out, but however you have things ordered, it still has to be in one single column. So I can change this to uniform, and you can see here, this clearly isn't formatted quite properly yet. It has an origin and then it has a matrix size. So this is basically the way that you specify the dimensions of the scalar field if you had this in a matrix form, for example. And if I just go into one of the ones I have set up here, you can see how this is set up with 87 by 61. I believe let's see if I just scroll to the bottom of this. Yeah, you can see how there were 61 columns and 87 rows of data originally. I'm just going to copy and paste that into here. And now you see this shape coming to life where each little square is one of the data coming from this data set. But what the scalar field has, let's go ahead and swap the layout here, close the data. If I open this up, the scalar field command has these different sections where you can expand them further to specify different options. So for example, for the color, there's a button called Refine that if I click this, it just smooths everything out. By default, it's black and white. There are some color ramps here that you can choose from. That's a little bit more vibrant than I might want to use. Anyway, you've got the rainbow. We also have a built-in color ramp for this file. So this sort of looks nice. So if you create your own color ramp, you can choose it here. But what I want to show you is how, if I go into the contours, if you want to add the contour lines, now I already have set up a list in this file in the column location. So I'm just going to put that in there so you can see what the contour lines look like. Oh, this is also a place where you'd want to specify the aspect ratio, force it to be 1 because this is physical data. And so what you see now right over here, there is a smooth button within the contours. And the effect here is probably really minor, but so let me zoom in on a region in space. So if I uncheck smooth, can you see how this is more jagged? But if I check smooth, now these contour lines are, again, they're much smoother. And that's basically the difference. So actually in 5.1, what we did was we added in the smoothing, 5.0 added in the smoothing of the contour lines by default. And we realized that did, there was an issue there with some files. And so in fact, this is now in the beta version that I'm using now has the smoothing option. So if you find that the smoothing in the release version, if you don't want that, then download the beta version and you can uncheck the smoothing option. However, I guess the other thing that we did is and this is, I think, in the beta, we made sure that whatever files you opened up would look the same. So if in the past they didn't have smoothing, they wouldn't have smoothing in the new version. So you know that we've been really emphasizing, I think, if you've been following the new example file interface and the fact that we are now, kind of organizing these, hopefully in a way that makes it easier to filter through and find the type of graphing that you want to use or to want to create. So what we're planning to do is have a deep dive into the example files and to highlight the basic files that are for data analysis, files that contain different layout options, the custom files, and then also the data sets. So every week we'll be kind of honing in on a different group of files. I'm going to build some of these from scratch just to show you some of the techniques that we use to make these, so you can build your own, or just give you some tips on how to effectively use these files to create your own graphs. I hope that this, again, was useful for you. And we currently have the first 2 videos in this series on YouTube, and the third one, as well as this one, hopefully we'll get those out for you next week. And I hope everyone is doing well and that you have a great week.